Today we're going to be talking about swapping elements in a linked list. We know that a linked list is a linear collection of data elements whose order is not given by their physical placement in memory, as opposed to an array in which we know beforehand how the data will be arranged. Now, over here we're going to have a linked list, and we also have this node.java file existing. So if you didn't watch my previous videos, I recommend watching the linked list one. That would really help you out for this one. So first we actually need to just understand the basic working principle of a linked list, and also the importance of the node.java file inside of this. So here we have this file, and then we have the linked list file. Now all we're gonna do is we're gonna get two elements and we want to swap them. So that's a very important problem in programming, but it gets even more important and even more special when it's dealing with linked lists, because we're not just swapping the element, but we're actually swapping the whole node. We're swapping two nodes, and that means we're gonna have to take in some responsibility. Swapping two nodes in a singly linked list is more difficult than it is in an array, because singly linked lists only have pointers from each node to its next node. To keep the list's integrity, you must not only locate the elements, but also reset the pointers around them. This entails keeping track of both the two nodes that will be switched and the nodes that come before them. This is a typical interview question because it thoroughly assesses your comprehension of the linked list. Suppose we have a linked list class, and we have this main method which is over here. The linked list has a test list object, and then there's a new linked list. So we're gonna actually create 10 different nodes in here. So we could just add in test list.addDetail. Suppose that there's a method and it just gets the I, which is the iterator here, and it's just gonna put all the values down here and just create our linked list for us with 10 different nodes. Once we do that, we could print this list out if we want. Then we want to swap the nodes. We get the list, and we also want to swap the third with the seventh one. So we want these two to switch places, the nodes with these kind of data. So we want the 7 one in the third place, and we want the third one in the 7th place. And then we want to print the list again. After this main method, so this is just the main method. Here is the public node head. By default, we know that a linked list contains a head pointer, so that's public node head. Now over here we have public static void swap nodes. We have linked list list, we have in data 1, in data 2. These are the two things that we need to swap, and then we have the system.out to print on just a greeting line swapping data 1 with data 2. So we're actually gonna do the following. First, we're gonna create the node 1, and that would be for our head. So we say list.head, and then we create our node 2, and that would be for the list.head as well. Then we're gonna create node prev node 1. Node 1 prev, and we're gonna have that assigned as null. Similar to that, we're gonna create node 2 prev, and we're gonna assign that as null as well. So these are the 4 variables that we're gonna be using throughout our program, because we have to take care of our previous nodes as well. First, we have the nodes, and we also have the respective previous nodes. Now, to find the node 1 and try to match it with the data 1, we could use a while loop. So I'm going to use a while node 1 not equal to null. What we could do here is we could say if the node 1 dot data is equal to the data 1, which was specified here in the input parameter right here. So what we could do is just break if we find it. And in the else case, we're just gonna go and set the node 1 prev to our original node 1. Okay, so over here it's node 1 prev, and over here is node 2 prev. And what I said over here is that node 2 prev will now equal to the node 1, which was originally there. And we're gonna change the node 1 now to the node 1 dot get next node. And this is a method that we created earlier in our videos. It just actually returns the next node. And if you wanna just assign it, you could simply assign it through this. All right, so let's just confirm what we wrote. We had a while loop that iterates the node 1, and it iterates if the node 1 is not null. So if we match the node's data with the data that we asked in the parameter, which is over here, then we break out the loop. If not, then we just assign the node 1 prev to be the node 1 that we currently access, and then we assign the node 1 to be now a next node after the node 1. So we're just gonna actually adjust the pointers here. And for the second node, which we created on the top, we just have to mirror this exact same logic here. So I'm just gonna paste it down, and now instead of node 1, we're just gonna replace this. So now we could just hold the Alt key down and press click to wherever you see node 1 and just replace it with node 2. So I could see it a lot of times here. And now I could just press the backspace and press 2. That's a cool trick in VS Code. Okay, so now that we're done with that, we just press escape and that would just return it. Now we need to update the preceding node's pointers. And those are the ones that are in the previous slot. And we have to keep track of that. That's very special about this problem. So what we could do is we could say if node 1 prev is equal to null, we could say list dot head is equal to node 2. And what this means is that if the node 1 previous is equal to null, so suppose that we have node 1, and if the previous to that was null, we could originally conclude here that the node 1 was actually our head, original head. And now we want to replace that original head with our node 2. So we could just simply write list.head and equal to node 2. So we concluded here that if the node 1 prev was null, then we could just simply write that. Updating the preceding node's pointers. So the first thing here says that if node 1 prev is equal to null, means that if the node 1's previous was null, that means we could originally conclude here that the first node was actually the head. So we could say list.head to node 2 because we wanted to swap it. Else we could just say node 1 prev dot set next node, and we set to node 2 because we were trying to adjust the pointers here of the previous nodes. And now if we want the node 2 prev is equal to null, then we'd have to set the head to node 1, or in the else condition we'd have to just reverse this. So node 1 prev dot set next node to node 1. So that's the logic here. So the final step here is to just perform that traditional swapping method. And what we could do here is we create a temporary node, and we could assign it with node 1 dot get next node. Once we do that, we could assign node 1, and we could say set next node to node 2 dot get next node. So this is done, and once we do that, we could say node 2 dot set next node to the temporary. And there you go, voila, we swapped our nodes successfully. It's important here to discuss the edge cases that could occur here. One edge case is that both of the nodes are equal to null. In that kind of case, we'd have to tell before that it's not possible to swap. So after the while loop is iterated, because when we iterate the while loop here and we come to a conclusion that one or maybe both of them are null, then there's no reason to swap them. So you could just type in this code, if node 1 is equal to null or node 2 is equal to null, then we could just swap not possible, one or more element is not in the list, and then return it, instead of going over this and wasting your computation cycles. The other edge case is that what if the data 1 and data 2 are the same? Now, I know this is not practical. Why would you even want to swap in the first place? But we have to make sure that if the data 1 or data 2 is the same, that we shouldn't even approach this function. So over here, when we create our 4 variables, we could just add a condition here to check if data 1 and data 2 are equal. If they are, then we just say the elements are the same, no swap needed, and just return the code. This will prevent us from a lot of computations that we don't require. Now it's time for the time and space complexity for this problem. The worst case for time complexity in swapNode method is if both while loops go till the end. So like these while loops will go till the end, either if there are no matching nodes or if the matching node is the tail. This means that it has a linear big O runtime of O of n. And if we look at the space complexity for this problem, well, we only have 4 variables that were declared regardless of the input, which means that it has a constant space complexity of O of 1. Thank you so much for watching this video. I hope this was intuitive and I hope you got a lot of benefit out of this. If you did, let me know in the comments, and if you didn't like this and didn't understand it, then also let me know in the comments. Thank you so much, and I'll see you in the next video. Peace out.